Bienvenidos, Ushamdi, and welcome CTS230, Section 841 students for the first 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 3 course, or the Scaling Networks V6 course from Cisco Networking Academy. And this afternoon's video tutorial and solution set is going to be on Packet Tracer Activity 7.1.2.4, where we're now going to be taking a look at how we can get a default route injected into our EIGRP Autonomous System routing domain. So let's go ahead and take a look at the activity here. We're going to be doing a default route for both IPv4 and IPv6. We're going to be operating on both sides here. And so we have all of the instructions are visible here on the right-hand side. So let's go ahead and dive in. So we want to verify EIGRP configuration on each IPv4 enabled router. So here's our IPv4 section over here, and this is going to be all IPv6 over here on the right-hand side. So let's pull the edge router up, because ultimately it would be the edge router who is going to advertise or inject a default route into this EIGRP domain. And so let's go from user exec with the enable command. We'll transition to privilege exec, and let's say show IP route EIGRP. And so you can see we've got two EIGRP learned routes. Now let's do a brief review here real quickly, because this is very, very important information. When we're looking at the output of the show IP route, keep in mind, and again, I'm going to stress that for the purposes of the CCNA, we are going to refer to this as the feasible distance. And I'm kind of lying to, I shouldn't say kind of lying to you there. Just remember, for CCNA, we're going to talk about this in the context of being the feasible distance. And so we can see our feasible distance is 2,170,112. Now we saw the same value going over another serial link that then went out a gig link, right? So we should be kind of familiar with that value. So to get to the 172.31.8.0/24, which is going to be this network segment here, that is going to be our cost, and the 9 segment, right? Because we're going out serial links. My guess is our cost here is $15.44, right? Because these are T1s or equivalent. And our gig link here is a cost of 10, right? So if we were going to be doing the equation, we would use those numbers for the minimum bandwidth, or actually, we would use that number for the minimum bandwidth, and then we would be taking a look at the delay values for each of those interfaces. If I remember correctly, it was 10 for the gig link, and I think it was 20,000 if I'm not mistaken. So again, that is our administrative distance, right? So let's say that we were also running OSPF in this environment right here. Which routing protocol would you see installed in the routing table? Exactly, you would see EIGRP, because the administrative distance for OSPF is 110 and the administrative distance for EIGRP is 90. So in other words, all things being equal, if OSPF was running on these 3 routers and advertising, right, the same networks, EIGRP would be what we see in the routing table, because only one of these is going to be installed in the routing table. The routing table is not going to say, oh, here's how you get to it with EIGRP, and then put a line down here saying, and here's how you get to it with OSPF, right? Because this would be redundant. We'd be advertising, or we'd actually have 2 entries in our RIB, right? That routing information database. We'd have 2 entries for the same network, right? With different protocols. And that's where the administrative distance comes in. Then we've got our feasible distance here. We see via, so here is our successor, right? There's the successor. How long have we known about that? 55 minutes, and here is the outgoing interface. So we have all the information required from the IPv4 edge perspective to get to both of those network segments. In fact, if we were to go ahead now and ping the PCs, I can quickly say ping 172.31.9.10, and we should have connectivity, and we do. And then what about to the 8.10? Whoops, to the 8.10. And we'll probably have a lost packet initially, but then we've got success, right? And then all subsequent pings are going to work. So what does our EIGRP configuration section look like? So let's work our way down here. And you can see it's actually pretty straightforward. Now, you'll notice that it says network 172.31.0.0, but there is no subnet mask over here, right? Or I should say, we don't see a wildcard mask indicating what that subnet mask might be. So what does this indicate? Well, let's go ahead and say show IP protocols. Let's check and see, is automatic summarization on? Well, no, it's not. It's simply that the configuration, right, when we put in that network statement, that we put it in so that it's going to go ahead and cover a classful boundary. So in other words, we did not go in and configure each of these networks individually as the /24s, I believe they are. And let's take a look at the interfaces here. Or actually, I'd have to be on the branch route. I thought it was on the branch routers there. So I'm pretty sure those are /24s over there. In fact, our addressing table could help us out. And yeah, they are, but they all fall under the same classful 172.31, because remember, a 172 is by default a /16. In other words, the default subnet mask is in dotted decimal is 255.255.0.0. So that's going to encompass everything over here. And so that's what we have as a single statement. All right, so now we've taken a look at that setup. Now it says propagate the default route into EIGRP. It says configure the EIGRP routing process to propagate the default route. Well, there's a couple of ways we can do this. So let's talk through how we're going to accomplish this. So from the edge perspective, why would we put the default route on the edge router? Exactly, it makes sense because on this side of the edge router lies everything else that we don't know about, right? So the edge router is going to be able to let traffic go from PC1 to PC2 and vice versa, because the IPv4 edge router knows about all of these 172.31 networks over here, right? But what's the problem? Yeah, if PC2 wants to go here, or PC1 wants to go here, do they know how to get there right now? No, they don't, because the IPv4 edge, there is no routing information in the routing table. If I was to say just show IP route, we don't have any information as to how we're going to get to that 64.100.1 network. And so what we want to do is, from an EIGRP Autonomous System perspective, we want to advertise from this edge router a default route down to these other routers here, right? Because if we look at the PC, and let's walk through this logically here. If we look at the PC and we go to the desktop setup, and then we take a look at the IP configuration, what is the default gateway? It's the 172.31.8.1, right? Which is that interface on the branch 1 router. So when PC1 says www.amazon.com, there's going to be a DNS lookup that takes place, right? And here is probably not the best example. There'll be a DNS lookup that would take place realistically. Here you can see the DNS server's blanked out, but the PC will do a DNS lookup. It'll get that host name to IP resolution, and it'll say, and let's assume this is Amazon here, we'll pretend, it'll say, oh, to get to Amazon.com, you need to go to 64.100.1.10. Now, PC1 is going to realize at that moment, hey, that is not on my local network here, right? Clearly, that is not on the 172.31, so I need to send that traffic to my default gateway, my default router, right? My safety net, whom I send all of my traffic to that I don't know how to get to on my own. So PC1 sends those packets here to branch 1. And branch 1 is going to look into its routing table to try to make a determination, hey, do I know how to get to, and let's look at that routing table here, do I have a more specific or a specific match, let's get into privilege exec, show IP route. Do I have something in my routing table that can help me get to that network? Do I know about that 64.100.1 network? And by looking at the routing table here, we can see, no, we don't. So let's see what happens here. When I pull the command prompt up and say ping 64.100.1.10, what's going to happen? Yeah, the destination host unreachable, because I'm sending those ping packets to my default gateway, who's responding with an ICMP packet telling me I can't reach that. I'm sorry. I don't have any information. So branch 1 is telling PC1, hey, I'm getting your ping packets and I'm your default gateway, but I have no clue how to get there, because here on branch 1, the gateway of last resort is not set. In other words, branch 1, unlike PC1, branch 1 router doesn't have a safety net. He doesn't have an outlet or a path or instructions as to where to send packets for which he does not have more specific information or an entry in his rib. So in other words, if branch 1 doesn't know how to get there and he's the default gateway, he's simply going to respond with an ICMP unreachable packet telling PC1, hey, I'm getting your ping packets and I'd love to help you here, but I don't know. I don't have a default gateway. So I don't know how to get there because I don't have a specific entry here telling me to take this interface as my outgoing interface or to go to this IP as my next hop. And so in this scenario, it makes perfect sense that the IPv4 edge router, being the only router with connectivity to the internet, that we would set the default gateway here on this IPv4 edge router. And so here we are in the IPv4 edge router. Let me say show IP interface brief, and let me do ping, oh, sorry, we're not in global config. So let's say just simply ping 209.165.200.226 or 227. Actually, it's probably, yeah, let's see, it should be 225 actually. Yeah, there we go. Because it's probably a /30 when we look over here, and the IPv4 edge 226, actually it's not a /30, but 225 is probably the IP of the internet. I can ping myself. Can we ping 7? And we probably cannot. Yeah, so it's going to be 225, and if I were to look up here, does it give us any information? It does not. So we've got to be able to sort out that it's 225 as the last octet. So let's get into global config, and how can we advertise a default route into EIGRP? Well, there's a couple ways we can do it. And the first is we're going to go ahead and do it. I'll refer to this as the points method, right? So this is going to get you the points. But we're also going to talk about another approach. So I'm going to say IP route, and I'm going to do my quad zeros, right? We should be familiar with that syntax right there. And then we're going to specify the next hop IP and the outgoing IP address. So the next hop would be 209.165.200.225. And actually I could do the interface, which was serial 010. And actually it's not going to allow me to put the IP in there as well. So I could specify both, right? Now we may see a warning that pops up here. I'm going to put this in here, and I love it when a plan comes together. So we get this warning here. It says default route without gateway, if not a point-to-point interface, which this is, right? This is clearly a serial connection, point-to-point. It says it may impact performance. And here's why it might impact performance if it's not point-to-point. And this is a very common thing that you see pop up here when you're doing your default configuration, is that what if, here's our router, let's say that that's the IPv4 edge router, and it plugs into a switch, which then plugs into this internet interconnect here that we've got. So here's our internet, and this is our V4, and I'll just put V4E for V4 edge. If it went into a switch, right, which is not a point-to-point connection, and maybe there are other routers that might be in that same VLAN on the switch, in other words, the same subnet, because we're talking about a /27 here, right, a .224. So we could have others in here. And if I simply say default gateway, and yeah, just send traffic here to this interface, we may end up needing to ARP to find the correct outgoing interface, right? So if it went into a switch and this was a multi-access segment, a broadcast segment, right, we could have some performance impact because there may be some ARPing that has to take place, right, that address resolution protocol, because we configure the interface, but we don't tell it the IP. And so that's why I was trying to show doing it both ways, doing it the way where you can actually put it in with the IP and the interface to where you would not see this error. Or you could just put the interface in, I'm sorry, or you could just put the IP in. So again, be aware of that. That's why you see that, is because you may have to ARP to get to where you're actually going. And so that was a pretty big chunk of change there. That was 25 points. So there it is. We've got the default route and we tell it, okay, use that interface. So now, is it going to work now from the PC? Or is there more to do? Let's check. Right. So remember, who's the default gateway for the PC? Is it the IPv4 edge router or is it the branch 1 router? And the same conversation for PC too. Is his default gateway the edge router or is it that interface on his local LAN segment in that same broadcast domain of the 172.31.9.0/24? And the answer should be a little obvious. It should be that it's not the IPv4 edge router because we don't have connectivity out to that 64.100, right? So again, we've got the address configured here, the default route, I should say, configured on the IPv4 edge. Now the question becomes, I need to tell my branch routers about this. So there's a couple ways we can do this, and I'm going to show you this is the not preferred way. Would now be to come here on the branch router and on the branch router configure a default route and point that default route to the edge. That's one way to do it. And again, this is, I'm sort of leading the conversation here into why dynamic routing protocols add value. So think about that. Here's my V4 edge. Now we've got the default route here that says go to the internet, and that's what we want, right? So put a little check there. We're good. So I could come to branch 1 and say, that's my default route, just like I did over here for the IPv4 edge. Just say, yeah, throw all traffic out that interface right there. And same thing on branch 2, throw all traffic out that interface right there for which I do not have a specific entry, right? And it's going to get to the IPv4 edge, and the IPv4 edge has a default route, and it's going to work. And let me show you that. Let me prove that that would work. So here we're going to say IP route 0.0.0.0, 0.0.0.0, and it's going to go out, where's my serial interface? 0.0.0, I believe. Yep. We're going to get that error, right? So now I'm going to come over here, and we're going to try to ping out to 64.100.1.10 from, and we'll take a look at that. Right now, you'll notice we don't get any points down here because that's not the goal of the exercise, right? The goal of the exercise is not to get it working, it's to get it working optimally, right? And I didn't say correct there, right? Because this is correct, this will work, but is it optimal? And the answer is no, this is not optimal. We don't want to have to go to all these routers, assume that off this edge router, we've got another router here, and another router here, and another router here, right? Do you want to have to go to 1, 2, 3, 4, 5 different routers and put default route statements in here if they're all already participating in our EIGRP Autonomous System. And the same conversation is true when we talk about routing information in general, right? Do you want to have to go to all of these routers and put in all of the routing information for all of the different subnets that they're supposed to be able to reach? And the answer is no, right? We're running a dynamic routing protocol, which means that we can dynamically propagate and advertise routing information into the EIGRP routing domain. So let's pull this statement off here because we don't need that, right? We're going to leverage the dynamic routing protocol EIGRP off of the IPv4 edge router to make this happen. And how do we do that? Well, this is where we go into router EIGRP, and I should probably check to see do show. So instead of saying do show run, I was just going to do a do show run because we're in packet tracer and I can't say do show run and trim it down to section router EIGRP. How can I find the autonomous system? Without doing a show run, how could I see what the autonomous system number is? Exactly, I could say do show IP protocols. And as it so turns out, it's autonomous system 1, right? Here again are the metric K values, which have to match between all of the routers, in the EIGRP autonomous system, or else the router that has the mismatching values is not going to form a neighbor adjacency. All right, so it's autonomous system 1. So router EIGRP 1. Now, if I do a question mark here, again, I've got a trimmed down version of the choices, but we see the choice here toward the bottom that we're looking for. I want to redistribute information from another routing protocol. Now, this also should give us pause, because if you're saying, well, wait a second, another routing protocol, because all I have is a static route. So when you hear protocol, you're probably thinking RIP, OSPF, BGP even, right? But I want you to keep something in mind here. In the context of redistribution, connected is a protocol. Static routes are a protocol. OSPF, EIGRP, RIP-v2, BGP, ISIS, everything I just mentioned there, they're all routing protocols, again, to include static as a protocol, connected as a protocol. And so my answer here is redistribute, and you take a look right there. I should have probably pulled this up first. So BGP, connected, EIGRP, OSPF, RIP, static, those are all in the context of redistribution. These are all considered protocols, right? When you see this statement here, redistribute information from another routing protocol, these qualify as protocols. And so we created a static route with which to use with EIGRP in order to facilitate the automagic propagation of a default route down to branch 1 and branch 2. And so we simply say redistribute static. Now you may be asking yourself, well, what if I have more than one static route? What happens then? Because I can create static routes for all kinds of things, right? Now, this is outside. Yeah, and you can see we can put a metric, so we can add a metric value here. We're not going to do that, right? So if I hit enter here, we're going to get our, 25 points probably? Yeah, and so it bumps me to 50, right? And this is the correct answer in this context. But think about that. What if I had more than one static route? What would happen? And if you're thinking that it's going to redistribute every static route configured on the IPv4 edge router, you are correct. Because all I'm telling it to do here is, hey, if there's a static route on here, and let's create a bogus static route just for the sake of this conversation. So if I were to say IP route and I wanted to go to, and let's make a network up, the 71.25.26.20 we'll just say 26.0 and then 255, 255, 255.0, and I said go out the serial 010 interface, right? That's a static route, correct? Because if I say do show IP route, now take a look. The gateway of last resort is set because we created the default static route. And here it is right here. And you can see we've got that little asterisk there, which if I roll up, you can see candidate default. And it's a static. And here it is. It says directly connected to serial 010. But what do you also see up here? You see the static, the bogus static entry, because there is no network in this activity. That's 71.25.26. But this is to show you that you need to think about this before you do this in a real world situation. Because now let's come down to branch 1. And on branch 1, let me say do show IP route. And what does branch 1 see? Whoops, and I didn't want to do that. Let's pull that back. What does branch 1 see? Exactly. Branch 1 now has a route. And what kind of route is this route? Why doesn't it show up as static here? Exactly, because what we've done is we did a redistribution from a routing protocol outside the EIGRP domain, i.e. our Autonomous System 1. And so routing information that has been propagated or redistributed from one routing protocol, in our case here, a static, into, right, this is foreign information coming into us from outside of our EIGRP domain. It's on the same router, without a doubt, no argument there, but it is foreign in terms and from the perspective of protocols, right? It's coming from another protocol, from another autonomous system. That makes it redistributed external EIGRP information. And that's why we see, and where is it up here? I know it's here. I'm looking right by it. There it is. EX is EIGRP. There's our D for dual, the diffusing update algorithm, external information, because I've taken it from the static protocol and I've injected it, I've redistributed it, I've injected foreign information into our EIGRP autonomous system. And that foreign information is going to be treated differently than information that we are learning from within our autonomous system. And this is how that information is depicted. So very, very important. Now we look over here and we see the administrative distance, the trustworthiness of this EIGRP information is less trustworthy than information that I've learned about from my trusted autonomous system neighbors, my buddies who are in the same neighborhood as I am, right? So think of it as like, this is my neighborhood here, and I trust the people in my neighborhood. But now I've got foreign, external people coming from a different neighborhood that I don't, I'm not too quite sure whether I should trust them fully. So I basically give them an administrative distance, a trustworthiness rating that is higher than my native neighborhood information from my autonomous system, right? And that's why the administrative distance is 170 for DEX or EIGRP external routing information, but that it's lower and more trustworthy when I'm learning it from my trusted neighbors here that we all live in this same autonomous system. Okay, so hopefully that's a good explanation as to why we're seeing what we're seeing. And again, giving thought to, hey, remember, if I start configuring a bunch of static routes on this guy here, they are also going to be redistributed into the EIGRP Autonomous System as external and less trustworthy than my autonomous system learned information. And that's why the administrative distance is different, because it has to say, EIGRP has to acknowledge the fact that if you had a route that you had learned from within your autonomous system, from your trusted neighbors here, that is going to be more trustworthy than information coming into you from outside of your trusted autonomous system, right? And it has to weight these separately in order to ensure that you always pick the more trustworthy information coming from your trusted partners here in your neighborhood. All right, so that's our IPv4 side of the house. Let's transition over here and now take a look at some IPv6 information. And if you're thinking that, whoops, and let's get rid of these guys here. If you're thinking that this is going to be pretty much identical as to what we just did, you are probably correct. And actually, I apologize. Let me be complete here and let's say, okay, now that the branch 1 router has that default route, which we can see right here, basically telling them, hey, if you don't have a more specific, longer match for a network, just throw it over the fence. Give it to the IPv4 edge, because he's telling us he knows how to get to everything that we do not have a longer, more specific match to get to. So we pull the PC1 up, we rerun the ping, and it works. And the same thing with PC2, we are going to see that it would work as well. If I ping 64.100.1.10, we've got connectivity, because again, here on branch 2, and I'm just pulling this up to make sure that you can see that in EIGRP, it gave it to both, show IP route. It gave it to both routers. And again, it gave both static routes to both of these branch routers, right? So very important. And the question becomes, what if I only wanted it to see that? And that is where you would transition into your CCMP conversation of doing filtering, right? You can filter what the IPv4 edge router is advertising. And then there's even another way to deal with it. And we talk about summarization, and I'll talk about that at the very end. So let's go ahead, let's finish this out here. And here is, what are we on here? IPv6 edge. So here's our IPv6 edge. So let's go ahead and say show IPv6 route. And here's all of the routing information. Again, a little more to work with, right? A little more to do here from a visual perspective, because we're dealing with IPv6, but our administrative distance for internal is the same. Our feasible distance for the context of CCNA study, our feasible distance is the same, right? Because again, the composite metric is the same. The administrative distance is the same. The commands that we use in large part are the same. We're simply adding v6 to those commands, right? So we take a look here. If I say show run, let's come down and look at our IPv6 router EIGRP. And you can see they've added that no shutdown statement. Remember, with 15.x releases, it should not be shut down by default, right? You should not have to go in there and say no shut, but make sure you check if you're having connectivity and reachability issues, because especially with the packet tracer activity or the CCNA activities that you work in packet tracer, because it looks like they like to leave this in here. They like to leave that on, right? And we've got our router ID defined as 1.1.1.1. Now remember, this is a router ID. If I say ping, and I'm going to go out on a limb here, assuming that this is not, let me say this first, show IP interface brief. And is there a 1. Okay, good. So there's no IPv4 addressing here, as you can see. So if I say ping 1.1.1.1 and I hit enter, am I going to get a response back? No, because remember, the router ID, while it can get its value from a currently configured loopback or physical interface that has an IPv4 address on it, right? It's not a reachable IPv4 address in all instances. So in other words, if it didn't get it from a loopback and it didn't get it from a physical interface, in other words, we configured it like we've done here, that is not a reachable IP address. Again, it is the router ID. And even if we get it from an interface, loopback or physical, in this context here, it is not an IP address. It is a 32-bit dotted decimal notation value that we are using as the router ID. And again, I like the fact that they didn't have it as a loopback somewhere here, and that we are getting to look at it in this context, because this proves it's not an IP. You cannot reach the router ID, right? Remember that. And again, you might be able to reach the IP address that it's using as its value if it's configured somewhere on the router. But when it is not, right, you're not going to reach it. So remember that. It is simply visually the same format as an IPv4 address, but it is the EIGRP router ID. And so we have that set up here. So now let's go ahead, and the order of operations here is the same. If I come to PC3, and this is going to be a little IPv6, always a little more work when we're doing our pings and we're taking a look at things, 2001:DB8, colon cafe, so they're making it a little easy, colon 3. So can I ping? No, we get an ICMP destination unreachable reply from the branch 3 router. Because the branch 3 router says, yeah, I know that I'm configured as your default gateway. However, I don't have a default gateway. I've got no clue as to how to get to that network you're trying to go to, that prefix, that 2001:DB8 Cafe 3. I have no clue how to get there. I don't have more specific show IPv6 route. I don't have more specific information telling me how to get there, right? These are the only networks I know about connected. Well, let me get down there. Connected or otherwise, right? So connected or otherwise, that's it. This is all I know about. And so I don't know about that 2001, because you don't see that in here, the 2001:DB8 Cafe colon 3. We see this Cafe ABCD, but we don't see Cafe colon 3 colon/64. So how do we resolve this issue? The same way we resolved it in the IPv4 space, right? Not that different. We come into global config with configure terminal, and we're going to say, well, actually, let's do the IP route. Now, whoops, let me make sure I get this right. IPv6 route :/0. Now, this is what I love this about IPv6, because it's a lot easier than saying 0.0.0.0, 0.0.0, right? It's just :/0, done. And we're going to ship it out the outgoing interface, which is going to be our internet-facing interface, because that's where we're going to send all traffic that we do not have more specific information for. And I'm scrolling up here, and it is the same interface, right? This goes out to the serial 010 to the internet. So we put that in there, and we're gifted those 25 points. And now we already know what to do. We simply go to IPv6. Boy, that transition sometimes is tough. IPv6 router EIGRP1. And we do our redistribute statement. And again, we're redistributing from another protocol, and static is considered another protocol. So now we come over here. Let's take a quick brief look here at the show IPv6 route, and there it is. Now, again, visually it's a little different, but EX, right? They took away the D because that was sort of redundant, right? Because when you look at the codes, remember, D stood for EIGRP and EX stood for, external EIGRP. So putting D and then EX is kind of redundant. So with V6, they've cleaned that up here. And it simply says EX, right? It's external EIGRP. And again, the same administrative distance as external IPv4. EIGRP information. And now we have our default route. So instead of having to go to branch 3 and put in a default route pointing to the IPv6 edge, and going to the branch 4 router and putting in an IPv6 default route to point to the v6 edge, we let EIGRP do the work. And so the benefit, right, the benefit and the ease of configuration may be a little lost here because it's not that many routers that you would have to put those default routes on, but in a realistic scenario where you've got 10, 15 routers, there's no way you're going to go to each of those routers and put a static default route pointing to your edge router in there. You're going to allow a dynamic routing protocol in IS to IS, EIGRP, OSPF, and IGP. You're going to allow the IGP to do all that work for you. You're going to configure it in one location on this IPv6 edge router and let it propagate throughout your dynamic routing protocol, your IGP autonomous system, to all of the member routers. And so now we move to PC3 and we say, let's try that ping again and take a look at that. We've got reachability. We'll come to to PC4. We'll come to the command line and we'll say ping 2001 db8 colon, is it cafe colon 1, I'm sorry, I think I was saying colon 3, colon 1, colon 3. I think I said cafe colon 3 earlier, but we would have been looking for 2001 db8 cafe 1, cafe colon 1 colon 3. And we've got that reachability. So the final thing I want to touch on here, right, is we talk about summarization and shrinking the size of the routing table. Let me ask you this. Is there another way, other than what I just did right here, redistributing a statically configured default route into EIGRP? What about summarization? And you're absolutely right. I could come to the edge router, and in some instances, there could be a use case where you want the summary, you want the default route to be advertised here, right? Because maybe this is a research and development network, and you want the default route to be advertised here, but you do not want that default route to be advertised down here. Because maybe you don't want the individuals, maybe this is a local network here and there's no need from a security perspective. You don't want your traffic going out the branch 2 router and then going out the internet. You want to isolate people here and keep them here. And so this is also a possibility that we can achieve through summarization. I could come here to the IPv4 edge router, and I could go into global config with configure terminal and go under the interface. Remember, we're doing summarization here. I could go under the interface, which is, I don't know, do show IP interface brief. What interface is that going to be? It's the 172.31. I'm sorry, I'm on the IPv4 edge, and the branch is going to be, I don't know what that segment is. I'm assuming that's 00. Let me do this. Interface serial 000 shut. Yeah, it's that one there. Okay, so no shut. All right. So we'll bring that interface back up. So I would go under the interface because remember, this is how we do summarization. I would say IP, summary address, EIGRP, and you can see our adjacencies back up because I bounced it by taking the interface down. And what autonomous system number am I participating in? It's 1. And what is the summary address? Well, what if I did that? What would that do? Exactly. That's going to advertise the default as a summary in EIGRP. So I could achieve it by doing that. In fact, you can see that the adjacency bounced there because of the summary, right? And I kept it on just that interface. So let's go into router EIGRP1, and I'm going to say no redistribute static. So when I come over here to branch 2, and hopefully this is going to participate, when I come over here to branch 2 and I say show IP route, where is my my gateway of last resort? Where is that default route? So it's not here. So then it would stand to reason that if I come to PC2 now, you got it. Branch 2 is going to say, hey, I've got no idea how to get there anymore because I'm not via EIGRP receiving a static default, or I should say a default route that was statically configured on the IPv4 edge router. And to wrap this up, if we come over to the branch 1 router and we say in privilege exec show IP route, and it looks like it's not going to, it looks like Packet Tracer is not going to entertain that summary that we configured there. So what it would say is we would see a summary here in EIGRP that would allow me to reach the IP, a summary default that would allow me to reach the IPv4 edge because I'm advertising that summary down across that serial link to the branch 1 router. So remember, there's always typically more than one way to do it, and this is how that would get done. In fact, did we lose show IP EIGRP neighbor? Did we lose our neighbor relationship? And it looks like we did. I think, well, actually, no, serial 000. We've got the relationship here with the edge router, but it doesn't like the fact that we did that summary. Do show run. Let's see, make sure it's still there. Did it allow me to keep it there? Yeah, it doesn't like the fact that we've got that summary in here. And what I was going to try to show was, remember, we talk about administrative distance. It's 90 for EIGRP, but for summary EIGRP, the administrative distance is 5, right? For summarized EIGRP information, it is 5. And let me make sure, yeah, it just simply didn't like it. It doesn't look like Packet Tracer is going to allow me to do that. But that is one way to do it. All right, well, that wraps up Packet Tracer Activity 7.1.2.4, where we talked extensively about getting default routing information into your EIGRP for IPv4 and your EIGRP for IPv6 autonomous systems. Thanks so much for watching. Enjoy the weather out there this weekend, guys. It is beautiful, and I will see you on Tuesday.